That should work. Yeah. Okay, welcome everyone. Good evening, and not sure what day or week this is, but welcome to this meetup anyway. So a little bit about us. We are the Orlando.NET user group. We also are the organizers of the Orlando Board Camp. That is the current makeup of our organizing team, but it's set to undergo some change. If you would like to connect with us and follow us for future meetups like these are some of the resources. So the best place would be on Meetup because that's where we schedule all our events. But I would also follow us on Twitter because we make quite a bit of announcements on there. If you need to email us, the email is at the bottom. Some other groups in the Orlando area that we highly recommend are the Orlando Backend Developers Meetup, Orlando IoT, Orlando Devs, which is a huge organization and they hold online meetups, and Azure Orlando. Just a quick note, we are recording this meeting and we will be uploading this meeting to Orlando's OneTug YouTube page. And on this meeting, please stay on mute unless prompted. If you have a question, just type it on chat, and one of us will pick it up and unmute you for the question. When you're asking the question, feel free to come on camera and ask, or if you don't want to come on camera, that's fine too. And quick intro, and then we'll get started. I'm really happy to have Steve Smith, aka Ardalis. Hope I got that right. Speaking for our user group, extremely pumped about it. Steve is an entrepreneur and a software developer with a passion for building quality software. He has published numerous Pluralsight courses. In fact, I think I learned about DDD from him. So thanks, Steve. He's also a Microsoft MVP and a frequent speaker at various conferences, mostly development-based conferences. He works with companies to avoid, to help them avoid the trap of technical debt, which is we all know is huge. So without further ado, I introduce Steve. Steve, you can share your screen now.
All right, thanks. Yeah, it looks like I'm wearing the same shirt that I was wearing in your picture that you had there. Let's see, there we go. You guys should be able to see a applying clean architecture slide.
Yes.
Hopefully. All right, awesome. And let me just keep the chat somewhere I can see it in case there are questions. Which it refuses to do. All right, well, I'll let you guys let me know if there's questions, all right? Okay, thank you very much for the introduction. I'm gonna go ahead and get started. I have a fair bit of content that I wanna cover this evening, and I know you guys are all busy, and even though you didn't have to drive very far for this meeting, you still have other things you may wanna be doing other than listening to me. So I wanna make this as short and sweet and valuable as possible. If you need to find me afterward, if you have any questions you don't get answered tonight, I am easily found either on Twitter as @Ardalis, or my email address is right here on the slide, steve@ardalis.com, or go to ardalis.com and find the contact page. If you want to learn more after today, here's a few resources. I'll throw up a couple more on the next slide. I do have a bunch of stuff on Pluralsight, including domain-driven design fundamentals, which is probably the most relevant to what we're going to talk about today, as well as a couple short courses on N-tier architecture that also drive home a lot of the same ideas that this topic covers. I have an ebook that's free that I published with Microsoft. You can download it from the URL shown here, or if you just Google eShop on web, which is a sample that I'll cover later in this presentation, there's a link to it right at the README file on that Microsoft sample. If your company or team would like any help with training or mentoring on writing better code, hit me up. That's what I do. So I appreciate it if you spread the word. And if you're a developer that's seeking to accelerate in your career or in your technical abilities, check out devbetter.com. It's a private group mentoring service that I've been running for about 1.5 years, and you might find that valuable as well. In terms of other places you can learn more from me, I have a weekly email I send out on Wednesdays with a tip of the week that you can sign up for at ardallas.com/tips, or a podcast that's also called Weekly Dev Tips but has different content. And then I'm streaming on Fridays, usually from noon to 2, and you can just show up and ask me anything. All right. So I like to start this thing off with some questions, which then I will answer over the course of this presentation. So if I were doing a real session, I might say, hey, does anybody have any questions before we get started? And usually the answer is crickets, because nobody wants to ask a question and they don't know what I'm going to cover yet. So I just kind of seed it with my own questions. All right. So the first one that we will talk about is, why do we separate applications into multiple projects if we do? What are some of the benefits that you might get from that? And then what are some principles we can apply when we organize our software into modules? And usually those modules correspond to projects in C#.net. What are some principles that apply there? And then how does the organization of our application's solution, how do we decide which things depend on which other things, where those project references flow? What effect does that have on our coupling? And based on decisions we make, usually early on in the application's life, what problems might we run into based on different approaches that we choose? Then, of course, we'll talk about clean architecture, and surprise, surprise, it addresses some of these problems, and we'll talk about how. And then we'll talk about how ASP.NET Core specifically kind of helps with some of these things with the new approaches that it offers versus legacy, ASP.NET or web forms or other approaches that have existed in the past. All right. So then let's kind of lay the groundwork with some principles. And so the principles that we're going to cover are things that relate to how we think about our software and how we organize its architecture. And when I'm talking about architecture and clean architecture here, I'm mostly talking about not so much physical architecture, like what servers am I hosting this on, and what type of load balancers am I using, and what's the network capacity, but the software architecture. And the definition of what I mean when I talk about that architecture is, what are decisions that are difficult to undo later, right? These are decisions that I can't just do a quick refactoring and change a decision, a couple months down the road. These decisions are difficult to change, expensive to change later on in the life of this project. All right. So take a minute, look at this refrigerator. This was the refrigerator at the Nimble Pros, former consulting company of mine that I sold, office. And, we did actually stage the stuff in there for the picture, but there are things in here that maybe don't belong. All right. And so we set this up for our software craftsmanship calendar that we sold 5 or 6 years ago. And separation of concerns, the whole idea of it is that you don't want to mix together things that don't belong together, right? There's a place in your kitchen for your meat that you're going to grill for lunch or dinner or whatever. And there's probably another place in your house for your toilet brush and plunger. And those two things probably, hopefully, aren't in the same place, right? And the same holds true in our code. There's places for different types of code that we're going to write and its responsibilities. And so the idea with separation of concerns is you want to avoid mixing those different responsibilities in the same place, in the same method, or in the same class, or even in the same project. And so the big three that we mostly think about here, and it's a good place to start, are data access, business rules, or if you're doing domain-driven design, this would be what you'd call your domain model, and then, of course, the user interface. So you want to try and keep those things separate from one another. If you're looking at a method and it's inside like a click handler of your user interface, and inside of it, it's doing a bunch of business logic if conditions, and then in those if conditions, it's writing directly to a database, you're kind of mixing all those things in one place, right? It's not following separation of concerns at all. All right, so that's kind of an example of what we're looking for here. And sort of related to this is the single responsibility principle. And in this image, this is a wired mouse, right, like a computer mouse, but it's also a Swiss Army mouse. And so here we've tightly coupled these tools together. So the likelihood that I'm going to need to use that corkscrew at the same time that I'm sitting at my computer with the wired mouse under normal non-pandemic times would be very low. Although I understand that day drinking has spiked dramatically in the last month or so. So maybe it's not as unusual as you would think. But the idea here is you don't want to have code that's doing too many different things all in one place, because if any of it breaks or if any of it needs to change, the effect of you making that change could affect all those other things. All right, so this works in tandem with separation of concerns, and the short version of the single responsibility principle, which is one of the solid principles. So if you've heard of solid but you haven't really investigated it much, check out my Pluralsight course on solid, and that should hopefully give you a good review of those principles. But the first one, the S, is single responsibility. And the short version of that principle is your class should only have a single reason to change. There should only be one change that a requirement might make, or that a business stakeholder might make to the requirements that would cause this class to change. If there's multiple different types of requirements that might change that would affect this class, then it probably has too many responsibilities. And I'm getting a note there that says my internet is unstable. Hopefully I'm not breaking up or anything. Everything coming through good?
Sounds good to me.
I'll assume yes. All right, good.
Yes.
Cool, thanks. All right, so the next principle is the don't repeat yourself principle, which you've probably all heard of. It's DRY is the acronym that you'll see. You want to write code that's dry. And so this is another image from those calendars that we did back in the day. And the idea here is that you don't want to repeat the same logic in your code. If you have repetition in logic, you can usually address that with some kind of an abstraction. And it also applies to your processes. If you have repetition in your processes, for instance, how you deploy your software, you can usually address that with automation. All right, but in the context of clean architecture, there's certain cross-cutting concerns that oftentimes are more difficult to abstract away with the traditional refactorings that most developers know. And there's ways we can address that better if we are following this clean architecture approach. So following the don't repeat yourself principle, we want to refactor repetitive code first into functions, typically. And then as we kind of go up the stack in terms of abstraction, we're going to group these into cohesive classes. Cohesive meaning that those functions all go together, right? They operate at the same level of abstraction, they work on the same data, they belong together. And then we're going to group those further into folders and probably namespaces based on whatever makes sense to us. Generally things like their areas of responsibility, their level of abstraction, things like that. And then ultimately we'll group all those folders into different projects. And projects is what we're going to talk about the most when it comes to how we organize things for clean architecture. All right, but we have one more important principle we want to talk about, and that's the dependency inversion principle. And this is sort of bookending the solid principles because this is the last one, the D in solid. And in this image, you can see that rather than using an electrical plug to plug into the outlet and get power, we're going to take this lamp, we're going to just cut the cord, and we're just going to solder it directly into the wall, right? And so when you have code in your application that is just directly newing up some dependency and calling a method on it, or worse, calling just some static method on something that has dependencies of its own, like you call a static method that makes a call to a database, right? You're hardwiring your code together. You're not making it easy to decouple it later on when you need to. And so the idea with the dependency inversion principle is that both your high-level classes and your low-level implementation detail classes should depend on abstractions. And generally in C# world, when we talk about abstractions, we're talking about interfaces. Okay, so we want our high-level classes, those are like our business level classes or domain model. We want those to depend on these interfaces. And we also want the actual implementations of those interfaces, the implementation details that know about SMTP servers and databases and files and low-level stuff. We want those to also depend on those abstractions. All right, so your classes ideally should follow the explicit dependencies principle. This is sort of a corollary, and it helps you to follow the dependency inversion principle. The explicit dependencies principle is much less well known, probably because I made it up and it's not, you know, someone famous that came up with it. But the idea here is that you want your classes to request all of their dependencies through their constructor. This makes your types honest, so they're not lying to developers when they try to use it. Think about this for a moment. In your development career, have you ever been working in a large code base? Maybe, you know, something that you didn't write, you know, you joined the team and they already had all this code, and you're trying to get something done. And you know this probably already exists, somebody's already done it, you don't want to reinvent the wheel. So you go looking through the code and you see, okay, look, there's this service that does what I need. And look, it's got this method and it needs these couple of things, and I can just new it up, and IntelliSense tells me, yeah, look, I'm gonna just new this thing up, and then I'll call the method I need and I build and everything compiles. You're like, great, I'm going home early. And then you run it, and the first time you run it just immediately blows up. And you look at the exception in the stack trace and it says, oh, I couldn't do my job because I needed this setting over here. And then you find that setting and read the docs and figure out what you need, give it the setting it needs, run it again, and now it blows up again. And it says, oh, I couldn't do what you want because this database doesn't exist or whatever, right? And you end up going down this rabbit hole trying to chase down all the dependencies that this thing needs, when it could have just told you up front. It could have said in its constructor, I need an iSettings object, I need an iConnection string, or whatever I need, whatever dependencies it might have had, right? It could have just told you. And then when you went to create it, you would know up front what you needed to give it. And ideally, if you're using an IOC container, you know, you just have to register those dependencies somewhere, and then it just provides them at runtime. You don't even have to figure it out when you're writing your code. So it provides a much nicer experience working with a system that follows this principle versus one that doesn't. And classes and services generally have a lot of hidden dependencies that you only run into at runtime when you try and use them. All right, any questions so far?
I don't see any in the chat so far.
All right, cool. Well, that's just give me a chance to take a drink. All right, so then the corollary to this dependency inversion stuff, the fact that all these things need to depend on those abstractions, is that those interfaces need to be defined somewhere in our solution where they're accessible from our low-level services and our high-level business services and the user interface entry points, because that's where we're going to wire all these things together. And if you've been doing ASP.NET Core at all, you're familiar with startup.cs, configure services. That's where you tell the services container what things map to what, right? And so the UI needs to know about all those things so it can do that work at that level. Now, before we get any further into that, let's talk about the difference between hardwired dependencies that don't use any abstractions and actually using abstractions in your code. And so if you look at this is actually from that ebook that I talked about earlier. On the left, you see compile time dependencies with class references where class A news up class B and calls a method on it, which then news up class C and calls some method on it, right? At runtime, the control flow looks identical. And I don't know about everybody else here, but when I first started programming, that's how I thought everything just worked, right? I didn't know there was another way. So of course, you know, the runtime is exactly what it was when I wrote it, because that's what I wrote, right? I didn't know there was any other way to do it. But later in my career, I realized that if you introduced interfaces into this, you created a very plug and play type of architecture. And it was really pretty simple to get this thing working. But now at compile time, class A knows about some interface, right, which B implements. Class A has no knowledge of class B or C, right? And class B, likewise, maybe it relies on interface C, does not know anything about class C. Now at runtime, I can still make it so everything works exactly the same as it did before, right? So my code is still going to do what it was supposed to do when it runs, but now I have introduced additional seams where I can write more tests or where I can swap something in and out and replace it with another implementation. And that turns out to be very valuable, especially in larger, more complex systems. And so this ties in closely with domain-driven design, because you should only be using domain-driven design when there is a lot of business complexity. And so when you have a large system with a lot of business complexity, it generally makes sense to have an architecture that supports dealing with that complexity, which is what this is all about. All right,
Steve,
so then,
there's a question
yeah.
In chat from Sam. He says, don't you always dependency inject at the class constructor? So
Don't you always, let me see if I can see this. I see Russ asking things. Is that who you're asking?
Sam Nandari.
Sam. Oh, Sam. I didn't think there was any other way. Okay. Okay, no. There's actually 3 types of dependency injection. And there's also just not using dependency injection. All right. So let's talk about different ways you can have dependencies. The first one, it's probably the one everybody learned first in a class-based language like C#, is you new up the class and you call methods on it. Right? There's no dependency injection at all. You're just directly newing up the thing. And so I've got a blog post out there and a phrase I like to use, which is called new is glue. Right? So every time in your code that you see the new keyword, you're gluing your code to that particular implementation of that class, right, of that type. The other way is you could just make it static, right, the thing you're calling. So anywhere in your code, you can just call any static method, right? That's another way you can do it with no dependency injection. Then there's constructor dependency injection. That's typically the only one that's supported by the basic tools, right? So if you've been doing ASP.NET Core for a little while and you understand how service collection works and you wire all that stuff up, any of those types that ask for things in their constructor, the services container will provide it to them. But you can also use 2 other types. There's method injection, where you have some dependency, you need to call some method on some type. Instead of just newing up that type, your method could request as a parameter, whatever it is it needs. Typically an interface, but it could even be the actual concrete type that it needs. And so now you have the ability to inject in a dependency that maybe only that method needs. Now, that is not as nice for many reasons as constructor injection. For instance, typically your IOC container, your services container, is not going to help you with that. So the calling code has to find that dependency somewhere in order to pass it. And so probably it will need to ask for it in its constructor, and you're just kind of moving around where the problem is. Now somebody else has to ask for it in a constructor. And then the third type of dependency injection, other than constructor and function parameter or method parameter, is property injection. And so property injection is sometimes useful, but basically the class that needs the dependency declares a property of that type, right? And then anywhere in that class where it needs to use that dependency, it just uses the property, right? Now this only works if the class somewhere up the line that called this thing sets that property to be the correct dependency. The basic services collection in ASP.NET Core, as far as I know, doesn't support that. But most of the third-party ones do, right? So like AutoFac, Structure Map, Lamar, all those different Castle Windsor, they all support property injection. So if you wanted to use that, you can. But that's another choice. So that was a long answer. Sorry, but hopefully that helps clarify a little bit.
Got it. Thank you.
No worries. Okay, yeah, Russ says the same thing. Yeah, the description of seams, I can't take credit for that. That actually comes from Michael Feathers working effectively with legacy code. But yeah, it's definitely a good way to think about what we're doing right here with these interfaces by introducing these seams. Okay, looks like we're good on questions. Let me keep on going. The other thing we want to do in our architecture, whatever architecture we create, and how we structure our code beyond the architecture, but even just our object-oriented design, is we want to make the right thing easy and the wrong thing hard, right? We want to force developers into a pit of success, because developers are busy, developers are lazy. They're going to try and get something done and basically follow the path of least resistance. If you've already got an example of a way to do a thing, they're probably going to just copy that and either literally like copy paste, or just look at it and be like, okay, this is how I do that, and follow that example. If you make things overly difficult, though, they're going to find a shortcut. They're going to find an easier way to do it. So if you've got code where the easiest thing to do is just call static methods to store things in a database, and everything in your system now is tightly coupled to the database, you're going to be in a different pit. It's not necessarily going to be the pit of success. And so we don't want developers to be stuck in the pit of despair with a lot of technical debt and code that you can't test and can't refactor. All right, so when we're talking about making the right thing easy and the wrong thing hard, there's things that we want to enforce here. We don't want our UI classes to directly depend on infrastructure classes, because then they're not following the dependency inversion principle, right? They should be depending on an abstraction. So is there a way we could structure our solution to help with this, to make it so it's hard to do that wrong thing that you shouldn't be doing? Similarly, we want our business domain classes, these high-level classes, they shouldn't directly depend on these infrastructure concerns either. And when I say infrastructure, I mean anything that has to talk to something outside of your code, right? So it has to talk over the network, it has to talk to the file system, it has to talk to a database, it has to talk to the system clock. All those things are infrastructure. They're outside of your code. And so we want to put those in a separate place because they tend to make our code harder to test, harder to change, slower to do things with. We'd rather have unit tests that don't have to deal with infrastructure. We're going to write some tests, integration tests, functional tests, that make sure everything works with that infrastructure. But our domain logic and our business logic, the most important part of the application, we want to be able to make that as easy to test and modify and change and evolve as we possibly can. And tightly coupling it to infrastructure leads you to the pit of despair. Okay. The other thing, coming back to that dry principle, is what can we do about repetition of certain types of things, like how we do queries, how we do validation, different policies we want to enforce, how we do error handling. Are there some patterns that we can apply here to make it so we can apply these in a sort of a cross-cutting way across the whole application without having to copy-paste them everywhere inside our code? All right. So that's pretty much the principles that we want to follow when we're thinking about this architecture. Now, let's back up for a minute and talk about classic N-tier architecture, because this is the typical approach that most folks are following if they aren't already doing clean architecture, and maybe they just don't know it, that's the name for it. And classic N-tier architecture has been around for about 20 years, probably longer, but in Microsoft land, it's been about 20 years. And I can prove that because this is this diagram that's from MSDN's website from 2001. And of course, it predated that by a little bit. But back in that day, .NET was very, very early. It was like still pre-release. And people were building things with active server pages and VB6 and things like that. And most of the ASP code that was being written was this far left side where everything was just mixed together. Right? You had some business logic, you had some HTML, you had some VB script, you had some record sets, and it was all just, you know, intermixed literally line by line with one another. And so the idea was we should split these things up. We should take the data access layer out, make it its own thing. That way we can get code reuse. We can kind of standardize on what that code looks like. We should take the business logic layer out, make that its own separate thing. Same reasons, code reuse. You know, you don't have, the presentation layer doesn't have to know about as much stuff, right? It only has to know about the business layer. It won't do end runs to the data access layer. And this was definitely an improvement. In fact, the very first conference that I spoke at was in 2001, and I had this in my slide deck because I was talking about how to build N-tier applications at that time. And so this used to be like the best practice, the way we should do things. And it was certainly an improvement over what we did in the late 90s. However, it suffers from this transitive dependencies problem, which is the data access layer directly depends on the database. Right? It knows about things like SQL connection and SQL data readers and things like that, or whatever your database technology of choice might be. And it only works if there's a database for it to talk to. You try and test your data access layer without a database, it's probably an exercise in futility. Then your business logic layer in this architecture calls directly into the data access layer. Usually it news it up, or it's literally a static helper that it's calling, right? And so it's tightly coupled to that data access layer. It's not easy to swap it out, right? And so that means the business logic layer also depends on the database. You can't test it without one. And the UI layer is the same way, right? And so what you end up with is everything depends on database. And so when I first started learning about testing and automated testing, and I realized, you know what, developers are expensive and computers are cheap and getting cheaper. Developers, by the way, are expensive and getting more expensive. Does it make sense to spend more and more developer time writing software and testing it and verifying it? Or does it make more sense to automate as much as you can of that testing overhead, that testing process? And so I started writing tests, but my architecture was this architecture, right? And so I didn't know how to write actual, what I would call unit tests, right? I was writing tests that had to go through the data access layer, had to have a test database. And very quickly, those tests got slower and slower and slower. And it just was sucking the life out of me and our team, because every time we'd want to run these tests, they would just take 5 minutes, and then later it was 10 minutes. And pretty soon you're not running those tests very often because they're just so slow. Because every single test that runs has to reset the state of the database in order for it to be valid and to run again. And oh, by the way, every time you add a test and it modifies that initial state of that database, you might break a whole bunch of other tests that were relying on the state that it was before. And they're not really broken. They mean, the tests aren't representing bugs. They're just failing because the setup is no longer valid. All right. So now let's contrast that with domain-centric design and the clean architecture, right? And so the idea here is we're going to take the most important part of our app, the business logic, the model of the system, the real-world system that we're trying to model in our software. We're going to put that at the core. We're going to say everything else is going to be dependent on it, right? So dependency points inward in this diagram using a circle. And so because all that infrastructure stuff, all the database and everything else depends on our business logic, it's really easy to test our business logic. It has no dependencies. By definition, it doesn't depend on any of that other stuff. And so it's really easy to write unit tests for it and have those run very quickly. All right, any questions still as I'm pausing to take a drink?
I don't see any questions. Jonathan does say that he loves the Princess Bride references.
Well, that's good. Princess Bride's an awesome movie. All right, so then the domain model is what lives inside the center of your application. It's not just your business logic, it's also a model of the problem space. And in domain-driven design, it typically includes things like entities and value objects and interfaces and services and other things, which I'll talk about later. It's also where you want to define the interfaces, the abstractions for working with your domain model. And then everything else in the application depends on these interfaces. Right, so this is how we're going to follow that dependency inversion principle. And this is where those abstractions need to live so that everything else can get to them. All right, so clean architecture is just the latest name for something that's been around for a while. It's been called onion architecture, hexagonal architecture, ports and adapters. Here's a slide that kind of shows what onion architecture looks like. And in here, we've got our domain entities at the center, and then around that, we've got our repository interfaces that we use to get to those domain entities. And then outside of that, we might have services. So basically, the very center is the domain entities. The next two circles are just interfaces for how to deal with the entities and the related services. And then the purple line is everything else, right? So those first three circles are one project. That's your core project. And everything else is your infrastructure, your UI, your tests, etc. All right, then this diagram is similar. This is showing ports and adapters, but you can also see where the hexagonal architecture name came from because somebody thought it would be cool to use hexagons for this diagram. If they'd use a different shape, it would have been called something else. But in here, these little purple circles that you see around the outside of that red and green domain layer, those are the ports, right? And the adapters plug into the port, just like you've got, outlets on your wall for electricity, and you've got adapters you can plug into those to draw power from them. And so in the top right, you've got an infrastructure layer that has maybe a SQL Server database implementation, but it also has an in-memory object store that you could use for testing. Either one of those can be plugged into that internal persistence port there. And typically the pattern name that we would use for that today is a repository, right, which is a domain-driven design pattern that's grown very popular. And a lot of developers have sort of a love-hate relationship with it at this point. But you can see the other types of ports that you would expose here. And those just represent abstractions that we're going to implement with things that are in other layers that depend on those abstractions. All right, so clean architecture has a couple simple rules. The first one is that you do not talk about clean architecture. No, wait, that's something else. First rule is that the application core contains the domain model. That's where all your domain objects live. And then related to that is all your projects depend on the core project, right? So dependencies always point inward toward that core project. Your inner projects are going to define interfaces that your outer projects will then implement. This is how we make sure that the dependency inversion principle works. Everything depends on an interface that's defined in core rather than the high-level things, depending on the low-level implementations, they depend on the interfaces. The stuff that's really hard to test, the UI and the infrastructure, we want to keep those at arm's length from our business logic stuff. We want to make sure the dependency direction flows from those things to the business model. So we want to avoid direct dependency, especially on the infrastructure project, except in our integration tests and maybe in startup.cs when we start the application, we have to wire everything up there. All right, so then in terms of the features of this clean architecture approach, it's platform independent. So I'm talking about it in the context of ASP.NET Core because that's what I know and what I develop typically. But it works with other platforms and other frameworks, right? Java or Python or Ruby or whatever you might be using. It's database independent. It doesn't care about the database. It doesn't care if you have a database. And it's UI independent. It really doesn't care if it's not a web-only framework. You can use it for other things. In fact, I have a GitHub repo that shows how to use clean architecture to structure a worker service that you might be developing that you want to host somewhere on Azure or AWS or something like that. One of its biggest features, and one of my favorites, is that it's very, very testable. So if, like me, you think that automated testing is the way to go to make sure that your code is easy to change and easy to verify that it still works, some weeks after you last looked at it, this approach is great because you can write lots and lots and lots of tests. They run very quickly, and they give you a good idea that everything is still working. Okay, so if you already have an application and you want to refactor it to clean architecture, there's a few different ways based on where you're starting from that this might go. So the best option is to start from a properly organized solution. And if that's where you are, if you have that option to your greenfield project, you're starting from scratch, then just go grab this thing off of GitHub. There's actually a project template you can install in Visual Studio if you want, and start from there. All right. Otherwise, if you have a single project, right, you have a relatively small application, it's only in one project, maybe you've got some folders for the different structures in there, it's pretty easy to take a single project and break it up into clean architecture, right? Grab that same template and then just start porting things into their proper locations. The hardest part is where you already have a large existing investment in a multi-layer architecture, like an N-tier architecture, that doesn't necessarily use abstractions or doesn't use them appropriately. And maybe the dependency directionality is wrong, right? Or it's not the way clean architecture would do it. That can be more challenging. That can take a lot of time and effort. That's where you might want to bring in someone with some experience to help you with that. There's lots of folks that I could recommend, or that's the kind of thing that I do as well. But someone could probably help you get that into a better structure. All right.
Quick question. What are the criticisms of architectures similar to onion architecture or hexagonal architectures that the interfaces, there are way too many interfaces, and it kind of has the interface soup problem to speak of. So is that something that you've heard of? If so, what is your recommendation on like how to best manage those or alleviate that particular problem?
Sure. Yeah, the criticism I hear is similar to that, is the interfaces make it hard to see what's going on, right? I really like to be able to just hit F12 and go to definition and see what the code that I'm calling is doing, type of pushback, or there's way too many files, right? I don't like the fact that there's a whole lot of files here, and trying to find something and navigate my solution is so difficult because there's so many files, and the two exacerbate one another, right? Not only are there all these interfaces, so I can't just F12 to see what something's doing, but there's so many files that I'm lost trying to find the right one. And both of those things are valid, especially if you're not familiar with this way of writing software. This is basically, if you follow solid principles, you end up with code that has a lot of small classes that do one thing, that use interfaces because, dependency inversion principle. And you end up with this type of code base. Yes, it has more files, and yes, it uses interfaces, and yes, it uses a lot of small interfaces because that's the I in solid, if you read that. And so you get a lot of benefits from that, but there's a cost to everything, right? Architecture is all about cost benefit trade-offs. And so if your application is simple and it's small and it doesn't need all that stuff, or maybe the team is small, maybe it's just you building this thing and you don't necessarily need to have all that abstraction and moving things around to make it more testable and easy to refactor, then maybe you don't need that, right? But if you have a larger application that has more complexity, has a team of developers that are all working on it, and you want it to still be changeable and testable, 2 years from now, 5 years from now, then if you go down the path of fewer, larger files that are tightly coupled, we know where that path ends, right? We've all seen that code. Whereas if the problem is just that you need to maybe learn how to use the tools available to you a little bit better to be able to navigate through a code base that consists of many smaller files. That's not that hard to do, right? It's not what you're familiar with or comfortable with. I used to be in that same camp. I've overcome that hurdle, and I'm in a better place, right? So, if you learn, Visual Studio has a search tool, Control-Shift-T, right? Do that, and then just type in a capital letter of each of the things in the type you're looking for. I'll show it if I have time when we get to the end of this. Use that all the time. Get in the habit of doing go-to implementation instead of go-to definition in your code, and you'll go to the thing that is actually running the code, which is what you want to see probably, instead of just going to the interface that you probably don't care about. So little things like that, little tricks that make you more productive and make it easier for you to navigate around your code base, I think help a lot. But there definitely is that pushback if you're not familiar with or comfortable with this way of doing things. It's not going to be what you're used to. There's going to be some friction there. All right, let's talk about what goes where, and then we'll show some code. So the core project, the center of your world in your clean architecture solution. What goes in here? This is going to have your interfaces. It's going to have your domain model, which is going to be your entities, your value objects, aggregates if you're using those. It's going to have domain services. Domain services and DDD are where you put stuff that doesn't belong in a particular entity, but maybe interacts with multiple entities. And so you put that logic into a service. It might have custom exceptions that belong at your domain model level. I recommend using custom exceptions for domain model things instead of low-level exceptions, especially null reference exceptions. If you can detect somewhere in your domain model that this thing is null and that represents that something wasn't found or something doesn't exist yet or whatever, then instead of just letting the null reference exception propagate up and developers have to track that down and figure out what the heck was null, which is always fun, you could have something that says order not found exception. Right. Well, now they know, okay, the order wasn't there. Got it. Okay, I can track that down a lot easier. And there's probably only a couple places in your whole code base where you're using the order not found exception. So it's a lot easier for them to search and find where that problem occurred, as opposed to a random null ref exception that could happen anywhere. Right. So custom exceptions go in your domain model. Domain events and event handlers go in your domain model. If you're not using domain events, you really should check it out, right? It's a really cool way to help decouple your code. We talk about them in our domain-driven design fundamentals course. I talk about them pretty frequently in my Twitch streams because people have questions about them. The wiring for them is already built into that clean architecture template. So you kind of get them for free if you use that template. And I'll show a demo of that in a couple minutes. But you should check out domain events if it's not something you're familiar with. And in specifications, that's another pattern. Specification is a DDD pattern for encapsulating a query as an object. And so this is another really nice pattern that not too many people use. It's not built into that template, but it is in another NuGet package. I have a specification NuGet package you can use. And I also have a good example of that in the eShop on Web reference application that I did for Microsoft. So I can show that here before we're done as well. All right, so that's the core project. That's everything that goes in core. Then the next project is the infrastructure project. And what goes in here is any kind of dependencies on out-of-process resources, right? So this is going to be your repositories for data access, and then whatever implementation you use for that data access, whether that's EF core, DB contexts, cache repositories. You could be using Dapper. You could be using whatever other data access technology you like. Any web API clients that you're using where you're calling some other network services, those clients should live in infrastructure. If you're talking to the file system, if you're doing logging to the file system or to a database or an event store, all that stuff should go here. Any kind of messaging, email, SMS goes here. If you have dependencies on the system clock that you want to be able to put a seam around, put the actual system clock implementation in here. Other services that have any kind of dependency on infrastructure, and interfaces. Let me talk about that for a sec. I said all the interfaces should go in core, so why would there be interfaces in infrastructure? Well, the reason why an interface would live here be if that interface has, as part of its definition, right, as its parameters or its return type, some type that is an infrastructure thing, right? So if I've got an Azure SDK and I've got an Azure blob storage thing that I'm returning back from an interface, I can't put that interface in core because now core has to know about the Azure SDK, right? And that breaks the cardinal rule that core doesn't have any dependencies. So those types of interfaces, if I'm going to use them at all, they have to live in the infrastructure project, which means that they probably won't get used anywhere except in the infrastructure project. And that's okay, right? Maybe some of these other services would use them and kind of wrap them. Yeah.
Quick question. So how do we, for example, I have some internationalization code. I mean, my exceptions, which are in core, I mean, basically the core, I have some messages that a business, I mean, which belongs to business. I want to internationalize them. I couldn't figure it out how to manage those, how to extract that out of the core so it doesn't belong there, it seems like, but I'm not sure how that can be handled in your experience.
If you can put the internationalization stuff into core, I would.
Okay. You can?
Because it's a business requirement, right?
Okay.
Like not all applications support it, although probably more of them should.
Okay.
But of the three places where that might live, UI, infrastructure, or core, it seems to me like it belongs in core 9 times out of 10, because somewhere you have a business requirement that says, hey, these things need to support, these 3 languages or whatever, right?
Yeah.
And so that requirement should be modeled in your domain model somehow.
Okay.
Right. And then maybe it's just an abstraction. Maybe all you have is an interface, right? You have some interface that knows how to translate string into language. But that interface, that abstraction knowledge should live in core.
Okay.
Now, getting it into an exception message, that could be tricky because it's not like you can do dependency injection on an exception, but there's ways to wrap the exception with some kind of helper that puts the correct string into it before it throws it or whatever. And I assume you've already solved that problem. You're just thinking about where to put the thing, right? So I would have no problem putting it in core.
Okay. Just wanted to understand. Thank you.
Now, if the place where it gets all the language details it needs, right, where it translates from one language to another is something in infrastructure, right? Probably it is. There's probably a file or a resource file or a database table. That's why you want in core, there should be the interface. And then in infrastructure would be the implementation of that interface that would actually know how to go get the thing from the resource file or from the table, right? And return back the appropriate string.
Got it. Okay.
Okay. Cool. So
I have
then,
a question.
Yeah, go ahead.
You're saying data, what is that? Come on. Domain model. So what do you mean by domain model? Can you give a bit of information about that?
Have you heard of domain-driven design? Right. Your domain model is basically like your business model. It's a model of the system, the real world system that you're dealing with, right? So if you're building an online shopping cart, which most of us are familiar with, you might have things like product and basket and customer, right? Those are entities that you're modeling in your software, right? That if you were in a real world store, you would have a real basket, right? There'd be real items you'd put in it, and there'd be a real, cashier taking your money, right? But we model all those things in our software, and that's why we call it the domain model, right? And the domain refers to the sphere, the area, the type of thing that we're modeling, right? In this case, it would be an online store, but it could be a blog, or it could be whatever the application's domain is the type of thing that we're trying to model, right? The problem we're trying to solve.
Thanks there, but
Does that make sense?
Yes. Is that different from the data model? I mean, we use a data model, which is database table, like when we put it into the
It's
entities.
usually very similar. Yeah, it's usually very similar. It doesn't have to be exactly one-to-one. And there will be things in your domain model that aren't in your data model, typically, right? If you have any complexity. Like, let's say that all you have is, you're writing a system that maintains the product catalog for this company. And literally all it does is provide CRUD access to a table called product, and users can edit the rows and add new rows and delete rows, right? Well, then you don't need domain-driven design. You don't need a domain model. You just need a data model in some way for people to edit it, right? But if you have logic that says, well, every time someone adds a new item, if it's for the US region, then I need to send an email to Bob because he's in charge of the US region, and he needs to know that that new product exists so he can sell it, right? Well, now that's not just a CRUD application anymore. Now that's got business logic. And so that logic still lives in the domain model, but you need to put it somewhere, right? It doesn't live in the database directly. It doesn't live in the data model. It's not going to be on the product table, but it is going to be in a domain event or a domain service or an entity or something like that, right? So the fact that you have custom business rules and business logic is what makes it necessary or at least worth it to have a separate domain model from your data model. If all you're doing is editing the data and there's no logic, there's no other stuff happening, no behavior, then you don't need domain-driven design and you don't need a domain model, and you probably don't need clean architecture.
Okay.
Does that
Thank
help?
you. Makes sense. Yes. Yes. Thank you
Okay.
very much. Yeah.
All right, let me get through the last one of these, which is the web project. Well, really it's the second to last. I'll show you in a minute why. So stuff that goes in your web project is all the ASP.NET Core stuff, right? So this is going to be your controllers, your views, or Razor pages if you're using that. It's going to be your view models, your API models, your binding models, whatever type of UI level DTOs you're using will go here. If you're using filters or custom model binders or tag helpers or HTML helpers, they all would live here because those are all ASP.NET Core things. You might have other services here that operate at the web level. So these would be services that either take in or return any of these things on this screen. All right, so if you have a service that returns back a view model, then it should probably live in the web project because you can't put it anywhere else because the view model is in the web project, right? So it wouldn't be able to live somewhere else and have that circular dependency. And then there might be interfaces here, but the same rule applies, right? The only reason you would have interfaces in the web project is if they're return or arguments use types that are defined in the web project. All right. Now you might have some things that are shared between different applications. Those go into something that D2D calls a shared kernel. And so these are ideally distributed as NuGet packages because then you can version them independently and you can still ship application A on a previous version of a NuGet package, even if you needed to have a breaking change made to that package that application B needed like right now, right? So it's generally a good idea to ship these as NuGet packages. What goes in here are going to be base types for a lot of those domain things, so your base entities, your base domain events, base specification. You might have common exceptions, common interfaces that you use everywhere in your whole company. You could have cross-cutting concerns like how you're going to do authentication, how you're going to be doing dependency injection. Maybe you've got a standard that you're going to use autofac everywhere, and you've got some common modules that you use for that. You know, that could live in a shared kernel. Same thing for logging. Same thing for maybe some common guard clauses. I'll talk about those real quick. Guard clauses aren't really part of clean architecture, but they do help clean up your code. And so a bad example of how to do if checks for arguments is what you see here, where you check if something's not null, and you check if the other thing is not null, and then right here you process the order, and then else you throw an exception of one thing, you throw an exception of the other thing, right? So all that if logic kind of obscures the actual work that you're doing inside of this method. A guard clauses basically says do a check, and if it's bad, exit immediately, right? So it looks like this. So if argument is null, throw exception. If the other one's null, throw exception. Okay, now we're done with all that checking. Everything from that point forward is the happy path, is just the good version of the method. And you don't have to think about all that other stuff, right? There's no if logic you're trying to keep track of in the back of your head of, okay, where's this else and what does it match up with? What guard clauses as a package does is you can use this NuGet package I've got, and it makes it so it's very consistent. So, if you want to always guard against something in a certain way, you want to always throw a certain exception, you want to always log it a certain way, right? You use this extension method for guard.against.whatever, and you can create your own for whatever you would need in your system. And then you use this approach to do those guard checks.
Question in
All right,
chat.
so when you're done, you have this structure. Yep, go ahead.
Miguel asks, how do you address conflict in the shared kernel? Like different teams wanting different direction on a particular common piece.
Sure. That's a political problem, not a technical problem. The idea of shared kernel and domain-driven design is that the only way changes happen to shared kernel is by consensus of all the teams that depend on it. Now, in reality, right, it's going to be Conway's law. It's going to depend on the org chart that your company has, whether or not that works that way. But ideally, everybody's on the same page. Where it's everybody holds hands and sings. I don't know. I forget the metaphor I want, but everybody's happy and there's no politics. But in the real world, there's going to be conflicting priorities or concerns or things. The nice thing about shared kernel is that if someone does introduce a breaking change, they will have a different version that has that change, and you at least will have time to incorporate that before you have to deal with it, because you could still be on version 1.2 and they've broken everything in version 1.3. Well, you just stay on 1.2 for as long as you can and keep shipping that code. Now, if it's a security hole or some other issue where you can't wait and the company tells you you've got to upgrade, then you're out of luck. But you at least have that flexibility where you could decide that you're not going to immediately address that breaking change. And I don't know how much that helps, but that's the reality of it from my experience. Okay, so in terms of dependency structure, here's what you've got. You've got shared kernel, it's a NuGet package. All the different core projects of all your different solutions depend on that and not much else, right? They depend on the framework, but they don't depend on other projects or other things. Infrastructure depends on core, web depends on core. When you actually want to build this thing though, web has to be able to wire up the infrastructure. So there's at least a soft dependency from web to infrastructure. And the reason why I say it's a soft dependency is it does not have to be a project reference necessarily. You can actually use reflection to just load that infrastructure DLL at runtime instead of at compile time, and then wire up all the dependencies like that. And I have articles that show how to do that. Why would you do that? Well, if you're really worried about developers falling into the pit of success and doing the right thing, if you really don't trust your developers to do the right thing in the web project, then you could set that up and make it impossible for them to just new up a DB context that's in the infrastructure, or just new up some other infrastructure thing in a controller in the web project, right? Because there's not a project reference. There's no way for them to do it. They would literally have to use reflection to go and load the thing to do it, right? And then all you have to do is watch the pull requests and see if nobody ever actually adds that reference. Typically, you don't do that, but if you wanted to, you could. All right, so then you have tests. You have different types of tests primarily for the different types of projects. So you have unit tests for core, integration tests for infrastructure, functional tests for web. When you do functional tests against web, it exercises all these other parts, right? It calls infrastructure, it calls core, it uses shared kernel, so that tests everything. Those functional tests are great. They're also more expensive, right? So you don't necessarily write as many of those. You don't need to write a functional test for every little helper method that you've defined somewhere in core, if you could just test that with a unit test. But you should test the main flows through your application with those functional tests. Okay, so that's important. That's kind of the high level structure and dependencies of the whole system. All right, so then the folder structure looks something like this. Typically, you just need 3 folders for core, infrastructure, and web, and then whatever your test projects look like. Okay, so then before we jump into the code, let me drop back for 1 second and talk about how we structure code in MVC for a minute. So let's think about what belongs inside your actions or your handlers, because this kind of ties into writing clean code and following clean architecture. Typically what you have is your action, or in a Razor page, you've got a handler. It accepts some type of thing, right? Some model that's bound to it. It does whatever model validation it might do. It does whatever it's going to do, whatever its actual work is. And then it creates some model that it's going to return, and then it returns an appropriate result type, right? It returns a view or a page or an OK with whatever model, right? API model or a page view model, for instance. Okay, so let's look at number 3, that do work step. What are we going to do in the controller? What belongs there? In the simplest case, where you don't have a whole lot of application logic, right? Maybe you don't have a lot of logic at all, in which case you maybe don't need all this abstraction, or you've encapsulated most of your business rules in the entities themselves, and so it's sufficient for you to just work at the repository layer, get the entity, call methods on it, and then save it, right? That's not a poorly abstracted system, as long as most of the logic is actually in the actual entities that you're dealing with. So this is good for simple stuff. The mapping between your web models and your domain model typically happens in the controller when you do this. And so here's an example of what that might look like. Here I've got a API method that takes a post. You pass it in the URL, you pass it in the ID of the item that you're marking complete. Think of like a to-do list. I'm going to say I'm going to mark number 123 complete. Uses the repository to fetch that item, calls the mark complete method on it, and then updates the item via the repository and returns OK. It doesn't have to return anything. Super simple. Okay. Now let's look at option 2. Option 2 works with an application service. So the constructor for your controller in this example probably won't have and probably shouldn't have any repository interfaces. It should only have service interfaces. And the reason for that is because it's a different level of abstraction. Repository is a very low level, dealing directly with persistence, whereas your application service is a little higher level, and it's just dealing with the application level of things, right? Not so much concerned with directly with persistence. Here you might pass the API model to the service. It is going to internally do whatever the work is necessary with persistence to do the stuff, and then it returns back a web model type. So because this application service knows about API models and web models and stuff, generally when I write these types of things, I put that in the web project because it has to know about those types. It's better for more complex operations. It does a good job of keeping your controller more lightweight, and so it looks something like this. So now this API controller, and imagine it has 5 or 6 different methods on it. Instead of having a bunch of code in there with the repositories and the entities that it's working with, every single one of these action methods is going to look pretty much like this. It's just going to delegate to a service to do the work. And probably where before the controller might have had several different dependencies in its constructor, now it probably just has one, right? It probably just has app service as its dependency. All right, so then option 3 is using a tool like Mediator, where instead of actually calling the service directly, we're just going to use Mediator to send a message. And then we'll have a handler for that message. And so it looks something like this. So now I'm going to create a command that says the message I'm going to pass. I'm going to give it whatever details it needs, in this case, the item ID. I'll call send on it. And then I'm going to have a handler that's going to actually do the work. And inside that handler, it's going to do the same work that you saw in the first version, right? It's going to pull the thing from the repository, call the method, and save it. But the cool thing about this is that now every one of my controllers, if I follow this pattern, only has one dependency. It only depends on Mediator, right? So all my constructors for all my controllers, they all look the same. They all just say Mediator. Guess what? Because of that, I don't need to put it on all my constructors of all my controllers. I put it on one base controller and have it know how to get the Mediator dependency. Excuse me. And then I don't need to have a constructor at all on any of my controllers, right? They all just use that dependency that's going to be on a property. This is an example where property injection works really well. And then they all just do this mediator.send. So they're all pretty short. But you can do this even a little bit cleaner. What if we do this? What if we say, you know what? I don't need to do the work of creating that message myself inside every action method. That gets boring. I've got this cool thing called model binding that MVC does for me. I'll just let model binding create the command that I'm going to send the mediator, right? And now every one of my action methods looks like this. It's 2 lines of code. I call send and I return the appropriate response. And if it's possible that I might get different types of responses, I want to return different things, there's a pattern for that too. It's called the result pattern. And you just have Mediator return back a result that then you have an HTTP or an ASP.NET Core filter that can filter from these generic results to the appropriate HTTP result, right? The action result. So you don't even have to put that if logic in your controller action. The filter just knows that, oh, if the mediator thing returned me back a result.not found, I'll translate that into an action result not found, for instance. All right. Now, there's even a better approach than this, which I'll show you in a minute when we get to the code. And you don't even need mediator for it. So we'll talk about that. Any questions on the slides before I jump into code? And I realize that ostensibly we're just past time, so I'll go as late as people feel like sticking around, and I'll make sure you get all the information you need on and where to get the code too.
Yeah, you're good on time.
Questions right now?
You're good on time. Someone had a question about where can I learn more about the mediator pattern. So I guess if you have any good resources on that, feel free to share.
I'm sure there's a Pluralsight course on Mediator. I've got a couple blog posts that specifically talk about this with ASP.NET Core. So let me pull this up. All right, so this is my podcast, weeklydevtips.com. This is devbetter.com. Let's get these things out of the way. This is my GitHub. It's got this clean architecture repository, also the guard clauses repository. So you'll find those there. The question about Mediator, if you just Google Ardalis Mediator, that's probably enough. You'll see using Mediator in ASP.NET Core apps. I'll show you how to set it all up. and you'll see this moving from controllers and actions to endpoints. For some reason on my machine, my blog loads up super slow. I think it's like a DNS issue. I'm told other people don't necessarily have it, but like that took like 5 seconds when it should have been instant. And it's saying it's not secure, which isn't right either. So I don't know, I gotta figure that out. But anyway, this blog, which I will paste into the chat, if I can find the chat. Where's chat? Chat, there. Yeah, and Mediator, I see somebody posted the GitHub link to Jimmy Bogard. This article should tell you everything you need to know about using Mediator to do exactly what I just showed you. And so that's what I would check out. All right, any other questions? Cool. All right, let's jump to
as far as time goes,
clean architecture.
As far as time goes,
Yep.
if you need to keep going, that's okay. I don't think we're necessarily constrained on time.
Okay. I mean, I don't need to keep going. I could keep going all night, although my wife would probably get annoyed with me at some point. But for now, I'm good. Okay. So this is the clean architecture template. Let me close down all these things. So it has a test folder in there. There's 3 different types of tests. It has a bunch of tests, not a whole lot, right? 11, right? This is not a Meetup says it goes to 8:30. Okay, cool. Yeah, I'm great on time then. This is not meant to be a reference application, right? This is not a sample app. This is a template. This is like when you say file new project. So it has some stuff in here, but it's minimal. It's really just there for you to kind of see how things fit together and then throw away the bits you don't care about. Okay, so in the web project, there's a few different things in here. When you do a new project in ASP.NET Core, first thing it does, it says, hey, do you want an empty one or a Razor Pages one or an MVC one or a Web API one, etc. I didn't want to have to deal with all that, so I put it all in here. So if you want to do an API, here's what APIs look like. If you want to do an MVC controller with views, here's what that looks like. If you want to use Razor Pages, here's what that looks like. And if you want to use endpoints, which I'll talk about in a minute, that's what that looks like. So you can pick whichever one you want. If you're only using one of those, just delete the other folders that you don't care about. Okay, in infrastructure, it has data. It's got an app.db context to do EF core stuff. It's got an EF repository, generic repository that's already built for you. So you really don't necessarily need much more than this for the vast majority of your systems. If you do, you can always obviously swap in whatever works for you. The other major thing this thing has is support for events built in. And so the way the main events work in here is, well, without getting into it too much, there's 2 types of domain events. There's pre-persistence and post-persistence domain events. And pre-persistence domain events are things that don't have any side effects outside of your system, where you have like, this entity wants to let this other entity know something happened in process, but I don't want to have a direct dependency between the 2. Right? And so domain events in that case can be a solution to that problem. But post-persistence domain events are for things where when the user saves their shopping cart, I want to send them an email telling them, thank you for your order. We'll send it to you within 24 hours or whatever, right? I don't want to send that email right when they click checkout, but before I save the order. Right? Because if I send the email first and then I go to save the order and I hit some database error and I don't have really good recovery and retry logic in my system, then I might not have any idea that I created that order until the customer a week later calls me up and says, hey, where's my order? I got this email and I don't even have a record of it in my database. I'm like, I don't know what you're talking about. Customers don't like that. They're not happy with that. All right, so I want these domain events to fire off after persistence. And so the infrastructure you need for that is here in the infrastructure project. I'm not going to go through it. It's just a bunch of junk to do scanning, looking for handlers. But I will show you this. Inside of save changes, in my DB context, I'm overriding save changes. I'm going to call the base one. And so if this fails, it's going to throw an exception. It's going to blow up. And we're not going to do any of the rest of this stuff. But if it succeeds, then I know I'm good. I know I've saved the thing. So now I can come down here and I can say, go find me all the entities that have events. And if they have any events, that's what this is saying, e.events.any. If they have any events, I want to loop over those events and dispatch them, right? Call their handler. And we'll see how that works in a second when I actually run it. All right, so That's mostly what's in infrastructure out of the box. You get basically EF core and domain events and like a email sender sample service. And then this is your domain model. So in your domain model, you've got entities. In this case, there's a trivial entity called to-do item. To-do item just has a few properties. Notice that you can't directly set is done. You have to call mark complete if you want to mark this thing as done. And so if you do, then it will set is done to true, and then it will add this event. When that event gets fired, there's a handler for it. The event's defined here. Right? Events are really trivial. Right? It's just a real simple, should be, well, this one's not actually, but typically they should be immutable. This one's probably a little bit too simple because I didn't make this immutable, but they shouldn't have any logic on them to speak of. They should just take in whatever state they need, and then you just pass them around and do whatever you want to with them. And then the handler accepts in that event, so it has this interface iHandle of T, of this event, and then that has an interface with a handle method that looks like this. In this case, it's async, because everything's async these days. And this basically lets you put whatever code you want to run. Whenever somebody marks a to-do item as complete, you put it right here. In this case, we're going to send an email. We're going to say this item was completed. All right. And while I'm here, let me delete my database. So we're starting from scratch when I run this. All right. So let's run this and see what it looks like. So here's the default page that comes up. Here's a list of to-do items that it creates when you first start. It's just got a basic seed method. Get the sample working, try and get it to build. Okay, that's done, it works. Review the solution, I just did that. Run and review the tests, trust me, the tests work, okay? So then there's a few different implementations of this. You can see it with MVC, you can see it with Razor pages, right? So this does the same thing as a Razor page. You can also go into the APIs and view those. So down here, these to-do items are in that to-do item controller. These ones are in the endpoints, which I'll talk about in just a second. So if we call this thing here and we say, try it out, execute, here's my get, there's my to-do items, right? So we've got those 3 items, they're all false for is done. I'm also running right now Papercut. Papercut is a test email server, which I just blogged about the other day. So if we come back over here, and we go to my blog, and we click on this link, and copy that over into here. If you don't have any experience with test email servers, there's a few different options here. There's a Docker one, there's Papercut, and then there's SMTP for dev. All of them work great. They all do essentially the same thing. But hang on, I needed that. The thing I want to do now is I want to mark one of these things complete and see if it sends an email. All right, so this one is not done. Its ID is 1. Let's go to this patch method, try it out, hit this, say 1, execute, and see if the demo gods are smiling on me. Now it says, look, is done is true. I get a 200 OK. I come back over here and I look at Papercut, and it says, look at that. At 8:13 p.m., get sample working was completed. Right, that's the name of that task. And then the body of it is status, done, get sample working, try to get sample to build, right? So there's all my logic, there's my email. And so that just shows that the domain event is working, right? So what triggered that domain event? Let's look at that again in here. So that was done inside to-do item. When I call mark complete, actually, let's go to the controller to show you. So here's my to-do items API controller, and that's this patch one. That's the endpoint I hit. So this is using this first version of the way that we could structure our actions. And we basically, it's literally the code that I was showing you pretty much. I think I changed it from post to patch at some point because it's more of a RPC call. But I fetch the item, I call a method on the item, and I call update, and then I just return the result, right? So that's as simple as it gets. So when we look at mark complete on the item, right, it doesn't know anything about sending emails. All it does is change the state of the item, and then it raises an event. And if anybody else cares that this happened in the system, then they can react to that event, which is what that handler is responsible for, right? So what if I needed to do other stuff when I mark one of these complete? What if whenever a to-do item on a list is marked complete or on a project is marked complete, and I don't have a list or a project in here, but let's say I had a a project as an aggregate of items. When the last item on the project is marked complete, then the project should be marked complete, right? And then other things should happen, other notification happen. We should send a bill to the customer that their project has been completed or whatever, right? All that logic can fire up from the event, right? Rather than having to have a whole lot of if logic right here inside of mark complete that has to know about this item, and has to know about the other items, and has to know about the project and everything else. I could put that just in an event somewhere else that does that work. The other thing is, notice that the way that I work with this domain model is through the entities, is through the objects, right? These objects are following good object-oriented principles of packaging together state and behavior, right? So I've got, here's my state consisting of these properties. It's got encapsulation because other things can't mess with my state, only I can. And then here is my behavior that represents, what I can do. The neat thing about this is that I don't have to give that up just because I have a dependency. All right. What happens in so many code bases is they give this up. They give up all of their object-oriented principles as soon as there's a dependency on something they need to do inside their behavior. So let's look at what that would look like real quick. Okay, so I'm here, and I have created a to-do list. Yay. And I've exposed this mark complete thing because someone said I should do it that way, whatever, right? As opposed to just saving the whole item again. And the business comes to me with this requirement, and they say, hey, when this thing is marked complete, you need to send an email to the person and let them know it was done, right? And we'll leave it alone as far as how you figure out who to send it to, right? We'll just say we know it's always going to be this email alias we're going to send to. Okay, so you're the developer. How are you going to implement that? It would be nice if we could just go into mark complete and implement it there, right? So that maybe that's the first thing you do. And you come into to-do item mark complete, right? And we're not using domain events. That's the whole point of this, is what would you do without domain events? And so in here, you've got options, right? You can say, well, I'm going to new up var email client equals new system.net email client, right? And I'm going to create right in here, I'm going to send the email. Right, well, this is bad for a lot of reasons, not least of which is that now you're tightly coupling your domain model to this infrastructure concern directly by newing it up, right? So we don't want to do that, right? That's going to make it hard to test. And so we'll scratch that. Okay. Well, I know I should use dependency injection, right? Let's just do this. I'm going to pass in this email sender that I've previously, somebody was nice enough to create for me. And I'll just dependency inject that right in here and use it like that, right? What's wrong with that? Well, the issue is that dependency injection doesn't really work on entities, because now when I try to fetch this thing with EF core is going to blow out and say, I don't know what that is. And so it's just going to die. It's going to say, you need to have a parameterless constructor for entity framework to work. And I can show you that real quick. Even if I just build this thing, all my tests and everything else fails on it, and I'll say I need to have a parameterless constructor. So what do? Well, I got to create a parameterless constructor. So I do this. Okay, well now email sender is null. And when I come down here and I call email sender dot, send email, right? I'm going to get a null ref exception right here. Right? It's going to go boom because I didn't actually pass it in. So I can't do that either, right? Unless I figure out some way to set this thing in the lifetime of this object, which is not immediately apparent to me, right? If I'm using a repository to fetch this thing with EF, there's nowhere in there that says populate its dependencies. Okay, so we're not going to do that either. Okay, so maybe I should pass in email sender here, right? So email sender here, email sender, right? Now we're doing basically property-based dependency injection. We already talked about why that's not great. All I'm doing is kicking the can down the road where now somebody else needs to give this to me. And that's okay, because I could come into now my controller here, and it could have to pass that in, but now this thing's controller needs to know about email sender. And it's not even calling any methods on that. All it's doing is passing it along to some other method it's calling. And if you do that a few times, you can imagine that this constructor starts to grow out of control real quick with a whole bunch of stuff that it's not even using. So that results in a crappy design. So we don't want to do that either. Okay, so what's left? I can't do dependency injection at the constructor. I can't do dependency injection at the method, and at least I'm not happy with the result. I don't want to just new it up right here. I could call a static helper. How about that? We could just have a static method called utils.send email, whatever. This is some static method. That'll work, but it's horrible as far as testability goes. It still has all the same problems with dependency. Okay, so what's going to happen probably is you're going to come in here to this some domain service here. We'll call this our to-do service. And you're going to come in here and you're going to say public void mark complete to do item, and it's going to say item.mark complete, and then it's going to say send email, right? And this to do service can take dependency injection. All right, so it'll work, and you'll come in here and you'll say email sender, email sender, control dot, all the things. Okay, so now this works, right? But that means that now in my controller here, I can't just work with the repository. I've got to also work with the service. All right, so now I have to come up here and I have to have iRepository and also, iDomain service or whatever. I'm not going to type it all out. And so then what happens is now my controller has two different levels of abstraction, which I already said I like. All right, so I have now repository for some things and this to-do service for other things. And developers don't like that. It's one more dependency. You don't know where to look to do what. And so what ends up happening, long story short, is that instead of having both of these things there, you end up taking all the different operations that you're going to do in here, and you put them on this service. And you end up with a structure that looks like this, where everything is just a service that you're calling to do the work, and you're just passing in the entities for the service to work on. Now, the problem with that approach, when you do it with domain services, is that all of your domain entities now start to look like this. They have nothing, right? They're just properties. They can't even have private setters because the service is going to be the one doing the setting. So these will be public, or maybe they'll be internal if you're lucky. But everything now will go through the service, and your entities become just DTOs, right? So you're not following any object-oriented principles. You have no encapsulation. Anybody in your system can mess with the state of this item, and you don't have any way of doing anything about that. So it ends up with code that's very error-prone and very hard to reason about its validity at any given point in time. So all that to say that the reason why I really love domain events is that you can get this encapsulation, and you can have side effects that use infrastructure, because this event doesn't impose any dependencies on infrastructure inside this entity, but these handlers can have dependencies on whatever services I want. They can have dependencies injected into them. And so that's how you decouple your entities from the infrastructure services that they might need to do their jobs. All right, so that's the clean architecture sample. I know we're getting close on time here. We're supposed to go to 8:30, so that's good. Let me show you eShop on web real quick. This is available here. Just Google eShop on web. This is a Microsoft reference architecture application that I wrote and maintained with a couple other people. There's a book that I wrote that you can download. It's a free PDF. You can also view it online. If you've been Googling around in the docs, you may have even seen some of it in there. It's not immediately obvious that it's part of a book when you see it there. But it's like 130 pages or so, and it covers a lot of these same principles. The sample looks like this. I'll run it. I'm sorry, I'm getting a little bit congested here. We're almost done. I'll just gut through it. It's running, and there it is. All right, it's a storefront. It has swag. It has mugs and hoodies and buttons and stuff. You can filter down to just .NET stuff. You can filter down to just mug stuff for both. It has paging. So if we turn this stuff off, you'll see it knows that we're showing 10 of 12 projects on page 1, and we can page to the next one. You can log in. The password and stuff is right here. You just copy paste it in because it's a demo app. And like that, you can log in, and now I'm logged in. Here's my orders. I can add stuff to the basket. I can change the number of them. I can check out, and I can go and look at my orders. And here's my order that I made. All right, so that's pretty much the sum of this application, right? It's a reference application showing how to do something that's a little bit non-trivial, right? It's more than just a solution starter. It's all open source. It's all on GitHub. You can download it. it has application core instead of core. That's because Microsoft made the unfortunate decision to name their product core, which was after clean architecture and onion architecture and all those things had been around, naming their things core. And they thought that would be confusing, and they're right, but it's their fault because they picked that silly name. And so that's why this one's called application core instead of just core. All right, so then it has all these tests. The main thing I want to show you in here that I think is interesting is the specification pattern. So the specification pattern basically lets you take, if you've got a bunch of code right now that has a bunch of link queries in it that are doing all the work of filtering, and you've got that Lambda stuff inside of your controller, or even you've got a repository, and that repository has half a dozen different methods for how to list something. Like list my orders. Okay, now list my orders for this customer. Okay, now list my orders for this customer with the items. Now list my orders for this customer if they're from New Jersey, right? And so you end up with all these different overloads on lists because of different ways you want to query it. With specification, you would define each one of those different types of filters and the shape of the data you want to get, including not just the criteria, but also what you want to include with it, right? Because EF Core has this notion of it's not eager fetch everything. You tell it what to include. And then other stuff like ordering and grouping and paging and all that stuff is all in here as well, right? So this is all in the base. I mentioned there's a specification pattern NuGet package that you can grab. So you can go here and just use our Dallas.specification specification and find it on GitHub to see what it has. That's there if you want to use that. We're probably going to wire that in here, so instead of having all this code in here, it'll just use that NuGet package at some point. But here's an example of the homepage specification. The homepage, you'll recall, lets you filter by brand or filter by type, and it also supported paging. So here is my link expression for doing the filtering, and then the paging is just calling this apply paging to do skip and take. I want to see the basket, shopping basket. It's just this, right? It's give me the basket for this ID, and oh, by the way, include all the items in your query. Customer orders, I showed you all the customers' orders, kind of the same. The difference being here, it's like for a given buyer, give me all their order items, and then include also the item itself that was ordered. That's necessary so that on this page here, I can get stuff like this image and the details of this item, because those aren't on the higher level basket item or order item thing that was fetched. So that's the specification pattern. This one doesn't really do much with domain events, I don't think. So you can look into this one if you want to see specification. You can look at clean architecture if you want to see domain events. And then the last thing I want to show you is this API endpoints thing. And this is a new NuGet package I've got, and it's in clean architecture now, but it's just a different way to structure your controllers. So this will take 2 more minutes and then we'll be done except for questions. So instead of having an author API controller to be able to create, update, delete, or whatever on author entities, right? So here's my author, right? It's got a name and a couple of properties. I'm going to create an endpoint for this. And so I just inherit from base async endpoint, and I specify the command, whatever the request is, I'm going to take, and whatever my result is, I'm going to return back from this. And those things are right here, right? So it's not hard to find them. They're chained directly from this endpoint. So this is basically modeled after Razor Pages, where Razor Pages has this page, which is essentially your view, and instead of having a separate folder somewhere with your view models and everything else, and your controller somewhere else, right? They're all tightly right together in one place. So in this case, the endpoint itself and the request and the response objects that it needs are all in one place. And the same is true for a get, and the same is true for a list and for an update, right? Everything is like that. And so each one of these follows the single responsibility principle because it only does one thing, right? It just has this handle async method. So it looks an awful lot like a mediator handler. In fact, essentially, that's what it is. And if you follow that approach that I showed in the slides, where we went from, this was the second approach, and then this was the third approach with mediator, every single one of your actions just says mediator send, Well, what I didn't show on this slide is that you had a handler somewhere for that mark item complete command that went with this, right? And it just accepted that command and had a handle method and then did the actual work. It looked a lot like this, right? That's what this does, right? It has the handle method, but I got rid of the need for mediator. Instead of having to have mediator in the mix at all, instead of having to have controllers at all, you just define an endpoint per endpoint, and you're done, right? What if you don't need all the different things? Maybe you don't need the create and the update and the delete, right? Instead of having a controller that maybe by default has all those from some template, you just create the specific endpoints that you actually need, right? And then they work with Swagger and everything, just like you would expect. So here's what they look like with Swagger. We already saw them actually here inside of this one as well. So they work just like regular controller endpoints do. They're just a nicer way to organize your code and keep all those DTOs together. All right, so any questions?
You can add filters and other stuff to this endpoint, just like any controller.
Yeah, you totally can.
Okay.
Here's the dirty little secret about these endpoints. Here's the types. They're down here. Base async endpoint is controller base, right? They literally are controllers. But don't tell anyone, right? Like if you wanted to, you could go up here on this thing and add another endpoint, another action method here, like you say HTTP get, whatever here, right? Because it's really a controller. But you shouldn't do that, right? That kind of goes against the whole idea. But then, yeah, assuming you follow the convention here, then they work with filters, they work with model binding, they work with everything because they're just controllers. And you can grab those also on NuGet, right? So NuGet API endpoints or Dallas should be like there. So there you go. 30 people have downloaded 1.0. So you could be the 31st one. Other questions?
Before people ask questions, will you be providing us the slides and
Yes.
also the sample code? Oh, there you go. Okay.
Yeah, everything should be here for the most part. I should add API endpoints to this, which I can do right now. It's just getting busy. Let's go API endpoints and eShop on web.
Steve, do you, I mean, is there anything from the existing GitHub, I'm not even GitHub, like, so open source that you contributed to, or like, I want to know, like, to read the existing contributors, I mean to say, so open source code and try to understand them, something like that. Is there any help that you can, like the easiest thing to
You
start
want
with
to
or something like
know,
that? I know
like how to get started with open
the
source?
different architectures, I guess.
Sure.
Yes, something like that, yeah.
Okay, I'm not sure I totally understand your question. If you were trying to just get started with open source, I would recommend you create a GitHub account if you don't already have one. You follow, watch, star, some different repositories that you think are interesting. You create issues for things where you run into problems and you try and follow the guidelines for those. If you see issues that maybe they say something like help wanted, like these help wanted issues down here, right? You could participate in those. You could, leave a comment or something and say, hey, do you still need this? And then if the maintainer says sure, then you could try and do it. And then when you've done it, you create a pull request.
Yeah,
and
I think I'm aware of that, but I'm just saying, like,
okay.
if do you have any of those that you already did, or anybody else? Like, I mean, I just want to see, like, when we are pushing something, like, how are we following the structure, or like how the things would
So
be.
you're
Just
asking
one or
for
two
an
examples of how.
sample project? Is that what you're asking? Sample project to look at?
Example project is one, so that we. I'm not sure even how exactly to put my question here.
If
Like, I want.
it's easier, feel free to send me an email and I'll definitely talk to you and figure out an answer
Sure.
for what you're looking for.
Thank you. Yeah.
Or if you think about it right now, it's fine too. Either way. Anybody else? Any other questions? I got that slide all updated with the other URLs. So there's the thing if you want to just like capture a screenshot or something. And yeah, I'll make the whole slide deck available afterward. I'll put it up on SlideShare or something so you can grab it from there.
I have a question, if you don't mind.
Yeah, go ahead.
Yeah, go for it.
Okay. Feel free to tell me, we'll take this offline if it's way too complicated. So I actually started my DDD life actually watching yours and Julie's Pluralsight, and I really love the idea of DDD, so I tried to introduce it to my team. We really dove deep into it. We all, tried our damnedest to make it all work out really nice. And because we're using EF, one of the things that actually I think kind of bit us in the butt was we kept our domain models as our entity models as well. So all of our domain models became our tables and so on and so forth.
Yeah, that's typically what I would do if you're using EF code first, whether EF6 or EF core.
Yeah. So the issue that we actually ran into is our models, because we also tried to follow the aggregate process of creating an aggregate model and then having all of our other models kind of hidden behind it. One of the issues we ran into is we have our aggregate domain model that may have references to other models that could have dozens and dozens. So when we go to load up the model in memory to process it, we have to load everything up because that's kind of the way that it's, at least that was my interpretation of it, is everything's supposed to be able to be loaded in the memory and you just work on it.
Right.
Which gets kind of bad when you start loading up way too much stuff.
Right.
Is there a cleaner way of getting around that?
That's where like theory and reality meet.
Okay.
In theory, you do want your aggregate to hold everything in it. And so if you tell EF to load the aggregate, it should load the whole aggregate, not just a piece of it. But that gets to be silly in some circumstances where you're like, but I really just want to display the customer's name on this page. Why do I need to load the customer and all their order history and all the products and blah, 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 right? And so there's a few different approaches to that, right? The first one is like, if all you need is the data for read purposes, you can create separate read models, as many of them as you want, right? They're still part of your domain model, but they're not the domain entity of that aggregate, right? So if you just need a way to display the customer's name, you create a read model that represents just the customer's name or a few little easy bits to query, and you fetch that and you display it and you move on, right? Because the main goal, the main value that domain-driven design gives you, and that aggregate with all its complexity is giving you, is the ability to enforce business rules when you do stuff, right? When you make changes, and verifying invariants that should always be true, and keeping people from doing the wrong thing accidentally in your system. Which when you're doing reads, typically none of that applies, right? So right away, if you're only worrying about read-only operations, you can a lot of the time just forget about dealing with that complex aggregate and all the complexity that goes with it.
That makes sense.
On the flip side, though, if you really do need to just work with that aggregate, but it's still just too big, then probably you just need to split it up and find a way to find a seam where it makes sense to break that aggregate up into multiple pieces. If you're finding that there are times where you're calling an operation and it only needs a subset of the stuff on that aggregate, and at other times you're calling something and it only needs a different subset of stuff from that aggregate, that's probably telling you that those two subsets could be two separate aggregates.
Yeah.
And that's a challenge. And I've worked with plenty of clients where it's like, well, we have this main God object, right? It's usually something like account, right? And the account is the customer's account, and everything else is off of that. And so that's our aggregate, and everything else lives off of account somewhere down the hierarchy. And we end up having to load the entire customer's history every time you want to work with their account. You have to try and find a way to break that up and make it smaller. And it's not always trivial to do, but it's worth it when you can.
No, I appreciate that. Yeah.
Does that help?
The models that it does. The models we deal with, we have multiple aggregates, and ironically, they all interrelate to one another in one form or fashion. So I've tried to be creative in the way that we I've been trying to be creative in the way that we can approach this, but it makes a lot of sense to actually introduce just read-only models, if you will,
That
just
yep,
to
that
simplify
part will help
life.
you a lot. Mhm.
Okay, appreciate that.
Yeah, and that follows CQRS too, right? Command query responsibility segregation. So you can kind of separate your whole architectural path of operations that are doing reads versus operations that are doing writes. And the ones that are doing reads just only hit the query objects, they only hit the read models. They might not even hit the same database as the other one, right? It might be that for performance reasons, you're hitting a read store that gets populated by the other database using events or something, right? To pass it data.
Yeah.
Usually you don't get into that for like simple, business apps, but for like really big scalable things, like if you're Twitter or something, you're going to have architecture like that where the reads are hitting an entirely different persistence structure than the writes.
Yeah. Cool. Thank you.
You're welcome.
I've got a question. It's a little bit of a two-parter, I guess. So it always seems like separation concerns dictates that you should probably treat your domain logic separate from a lot of the rest of your model. But that always seems to be a little bit of a problem when an awful lot of business logic ends up kind of leaking into the UI, especially with rich client kind of stuff. And these days we see an awful lot of rich client work being done. So an Angular app or whatever, a lot of that's going to have to be ported over in TypeScript or whatever. So do you have any kind of tips or guidelines for how you can push some of this stuff like domain events or whatever into the client side of things, or how we can approach that problem, if that makes sense?
Sure. We're lucky now that we have technology like WebSockets and SignalR that make it easy to communicate back and forth from the single page rich clients, whether they're Angular or even phone apps or whatever, with the server a lot of the time. So if you really want that logic to live on the server, maybe because it's proprietary or something like that, and you don't want it to even be out in the hands of customers, then you can use techniques like that to still behind the scenes go and talk to the server to get that data. You don't usually do that though. So typically what you do is you've got the logic in multiple places, right? You've got the logic in TypeScript, in Angular, to kind of let the user know what they can and can't do and to do validation. And then it's going to interact with your backend service through some kind of API endpoints. Those API endpoints have to do all that same logic again because you can't trust the client at all. They might not have JavaScript turned on. They might just be poking at your thing with Postman or something like that. So you can't count on the fact that your Angular code had this beautiful TypeScript that made sure that they could only get the system into a particular state before they hit that button. They could still be posting any kind of garbage they want through other means. So you don't really have a choice but to also do validation logic and any type of consistency checks inside your server-based application as well. Is typically how it ends up working. So you can kind of think of everything you're doing in the rich client app as being just all about UX, right? It's just about making the user experience better. It's not about security. It's not about ensuring that your domain is in a consistent state. Your domain lives on the server at the end of the day. And so when they finally do some kind of a post back to the server with whatever it is that they've been manipulating on the client, you have to do all those checks again and make sure that it's in a good state before you let them proceed, right? And if it's not, then you react accordingly. You might just throw an exception and blow up the whole world, or you might come back and say, oh, sorry, you need to change this one thing, to make this thing valid or whatever, right?
Right. So kind of some duplication is probably
does that
going to be
help?
involved. Yeah, for sure. Yes. Thank you.
Yeah, there almost always is. Now there are frameworks and there are approaches that you can use to try and reduce that duplication. Especially on the validation front, there's lots of widgets and things that are built into MVC or that you can get from third parties where you can kind of define the rules of the message structure in your API and then, code gen that basically in your client code to have, the same rules that you have on the server. Blazor is shipping this month theoretically, and Blazor would let you have C# code running on the same models, which maybe have the same validation logic on those DTOs, like using component model annotations for things like required or range or things like that. And then you could easily not duplicate that validation logic because in Blazor, it would be using the same code on the rich client as on the server. But it sounds like you're using Angular, and so you don't necessarily have that. There are other frameworks, and I'm sure somebody's got a commercial one for Angular, where you take the server-side code and you generate the validation logic or the business objects you're going to work with in TypeScript that Angular is then going to use. So you might, if that duplication is bothering you, you might find a way to kind of keep it in sync with some code gen solution.
Mm-hmm. Right. Good point. Thank you very much.
You're welcome. Wintermute's an awesome name, by the way.
I appreciate that. I'll pass it on to the family.
All right. I
Anyone
don't
else?
see any other
Hey, Steve, I
questions.
guess I was trying. Yeah.
Go ahead.
I was trying to put my question earlier. Maybe it comes boiled down to like this: like whenever I see the code, it would be difficult for me to identify the patterns if there are using anything of that sort. So, is there any quick or exercise or somewhere you feel like that would help me to check out? I mean, I'm working fine. I'm doing everything, whatever I need to do in my job. Everything is good. But sometimes I feel like if something suddenly comes, I have a little problem in architecting. Like, this is how I have to bifurcate my classes. Like, this is how I have to not to do. This is how I have to do.
I would look at
Yeah,
these two
I'm slowly
courses
following these
on my
actually.
Pluralsight, if you have access with Pluralsight. So like
Yes,
solid
yes, I have.
principles
Yeah.
and refactoring would be huge. For this course, domain-driven design fundamentals would be one. I mentioned these N-tier courses. These kind of tie into the whole solid thing. They're a little bit old now, but they're evergreen content. I mean, the principles haven't changed. So those would be the places I would look. And then for other like actual design patterns, there's a whole design patterns learning path that used to be a design pattern library that's I think still out there way back here from 2010, but they've been retiring it and replacing it. So there's probably some note somewhere on here that says this thing's retired. I guess you have to log in to see that. But they have a new learning path that they're doing that I've been redoing my patterns for. So you can see there's the adapter and the proxy and the singleton, and I've got another one coming out probably in the next day or two. So you can check those out as another resource. And not just from me. I mean, there's a ton of good content on Pluralsight. That's probably where I would point most people for quality content that I usually trust, right, as opposed to whatever you might get on YouTube.
Cool. Sure. I'll do that. Yeah.
Okay.
All right. Now I think we're really done.
All right.
So,
well, thank you very much for having me. I hope you guys enjoyed this.
Yeah, thank you, Steve. Thank you for coming, and thank you
very
all
much, yeah.
for attending. And
maybe I can come down sometime when we're not in the middle of a global pandemic, and I can check out all you guys in person.
Yeah. So the story behind this talk was that it was scheduled to be an in-person talk when Steve came down for Dev Intersection, and then that got postponed. So obviously, I guess this is the best we can do right now. But I think this was a great venue because we had a guy log in all the way from California to watch this talk. So that's pretty cool. So so thanks for coming, Steve, and thank you all, and stay safe. I will upload this video to our YouTube channel, and you all can find it there. Thank you.
Awesome.
Thanks a lot, Steve.